Good morning, mathematicians. Today we're doing lesson 1.2, points, line segments, lines, and rays. The goal of this lesson is to introduce tools for geometry and to review points, line segments, lines, and rays. Before we get ready, you need to check and make sure you have all of your supplies. Do you have a pencil? Do you have your folder with your learning journey in there? Do you have your math journal? And do you have a board, a marker, and an eraser? Give a thumbs up if you are ready to get started and you have all of these supplies. Each day, remember, we start with setting our learning intention, which is like our learning goal. On your math journey sheet, we are on day 2, and then you need to fill in the date. Today is 9-14. You can see on here that the learning target today is I can name, draw, and describe rays, lines, and line segments. So we then go over to our learning intention sheet and we find the second box. In the second box then you need to have today's date, so 9-14-15, lesson 1.2. Now our sentence starts with I will be successful when I can. How would we continue this sentence if our learning target is what's listed right up here? Give a thumbs up when you have an idea of what it would mean to be successful in today's lesson. Go ahead and pause the video when we turn and talk about what we could write for today's learning intention. There are a lot of different things we could write here, but one way we could show that we are successful is when we can explain what a line segment, or ray is. So once we can explain what one of those is, then we're good. Let's go ahead and do the warm-up. You know you will need your board, your marker, and an eraser. On the left are the problems we all must do. If you finish before we start going through the answers, you may continue with the problems on the right to warm up. So you must start on the left, and when you're done, you continue on to the right. Remember, do not write the problem, only write the answer. Go ahead and get started. Let's check and see how we did. I will say the problem, you say the answer. 9 minus 0 equals 7 minus 2 equals 11 minus 1 equals 12 minus 6 equals 14 minus 6 equals 16 minus 9 equals 12 minus 7 equals 70 minus 30 equals, and 140 minus 70 equals. Go ahead and erase your board and set your board, marker, and eraser down. We will know you are ready to continue when your hands are free and your eyes are up front. In this unit, we are studying geometry. Geometry is all about different shapes and patterns that are around us. I am going to go ahead and read from the math reference book. As I do, you need to listen closely for 3 places where geometry can be found in our world. The world is filled with geometry. There are angles, segments, lines, and curves everywhere you look. There are 2-dimensional and 3-dimensional shapes of every type. Many wonderful geometric patterns can be seen in nature. You can find patterns in flowers, spider webs, leaves, seashells, even your own face and body. The ideas of geometry are also found in the things people create. Think of the games you play. Checkers is played with round pieces. The game board is covered with squares. Basketball and tennis are played with spheres. They are played on rectangular courts that are painted with straight and curved lines. The next time you play or watch a game, notice geometry is important to the way the game is actually played. The places we live in are built from plans that use geometry. Buildings almost always have rectangular rooms. Outside walls and roofs often include sections that have triangular shapes. Archways are curved and are often shaped like semicircles, half circles. Staircases may be straight or spiral. Buildings and rooms are often decorated with beautiful patterns. You see these decorations on doors and windows, on walls, floors, and on ceilings, and on railings of staircases. At this time, we're going to pause the video and discuss some different places where geometry can be found in the world. When we study geometry, we're going to be using a variety of tools. We will use a straight edge, a geometry template, a calculator, a ruler, and a compass. It's very important to remember that all of these are tools that we use in math to help us. They are not toys. That means we should only be seeing these getting used for their purpose. Nothing should be getting swung around or played with like it is a toy. The straight edge could be the edge of a folder. So if we need to draw a straight line, we can use the edge of a folder or the edge of a math journal, anything that is straight. That's called a straight edge. A compass we used when we made our compass projects. It makes circles. The geometry template has a lot of different shapes. It has a protractor on, and it has a ruler on the side. This is also an example of a straight edge. The calculator we use in 4th grade and you will use in middle school looks like the one up on the screen. It's important that you do have one of these to use. And lastly, a ruler, another example of a straight edge, is a tool that we will be using. We're going to take a look at lines, line segments, and rays, and talk about what is the same and what is different with each. Keep in mind that before you leave the rug today, you will be writing an exit slip or a journal entry explaining the difference in all 3 of these math terms. The first thing we're going to look at is a line segment. A line segment is straight and thin. We would draw it with a straight edge, and it has an end point or a dot on both sides. Each of these are labeled, so it might be labeled A, B. It has a beginning, it has an end. Mathematicians take some shortcuts or have abbreviations for ways that they write out the name of things. So instead of writing in all words, this is line segment A to point B, they would write the 2 endpoints and put a line segment above it. Or we could switch the order and call it line segment BA. When we're working with a line, there is no beginning and no end. It again is a short and straight line segment, and then we put arrows on to indicate that it continues forever. We could label again a point A and a point B, and then when we name this, we would write down it's A, B, and we draw a line segment with arrows over it. Or it could be BA. So when we read this, we would say this is line AB, or this is line BA. It doesn't matter what letters are up here. We could have ended up writing that this was a C and a D, and then down here we'd label line CD and DC. Now imagine a line segment that goes on without end, but only in one direction. This is what a ray is. So again, we draw a line segment. One side has an endpoint, the other has an arrow. we do put another point here so we can name the ray. Let's say this endpoint was called X and this point was Y. We can only name rays one way. We always name the endpoint first and then the point. And then above it we draw a ray showing which direction it continues. This is ray X, Y. Let's try that again. If we had a ray going the other direction and we labeled it N and O, we would then start with the endpoint, so with O, and then N, and then draw the arrow going over the N because that is the direction that it continues. We're going to pause here, and teachers, we're going to have students show with their hands how to make a line segment, and a ray. Go ahead and practice this now. So let's review with this example. Up above, we have an X, a Y, and a Z. All of these points are on what appear to be a line because it has an arrow and it continues infinitely on both sides. What are all the line segments that we can name from this line? Remember, you only need 2 points for a line segment. So let's see if we got all of them in our group. We could call this line segment X, Y, and we could switch it around to YX. We could also call it YZ or ZY. We could also take the 2 outside points, X and Z, and then we could call this line segment XZ or ZX. Let's do the same now with the lines. Go ahead and turn and talk. What are all of the names for the lines up above? All of the names would be the same as what we had for the line segments, except this time, above each of the points, we need to have a continuing line. So we have XY, YX, YZ, ZY, XZ, and ZX. Now remember, a ray has one endpoint and one continuing side. So go ahead and turn and talk. What are all the different rays you can make up above? We could start right at X and continue through Y. We could start at X and continue through Z infinitely. We could start at Y and continue through X. We could start at Y and continue through Z. We could start at point Z and continue through Y or Z to X. Today when you work, this is what your 2 journal pages will look like. This first one is page 4 in your math journal. You will be practicing drawing points, line segments, lines, and rays. Make sure you follow the direction when it says to use a straight edge. You then started these math boxes already. You will get them completed. Take out your learning journey again. There is a thing that we need to switch on here. So the first thing we're going to do is we're going to do our journal right activity right on the rug. Then go back to the top of the list. You'll do Math Journal page 4, Math Box 1.2, and then you are going to be playing Addition Top It, the extended fact version. We always do games last. We finish our Math Journal page and then go to the games. So even though it's listed here, it needs to be last. This second one should be crossed off. We are not entering goals in our online portfolio. With the game, note that you do need to write down some of your answers on a Math Master sheet from the middle room, and the directions are in the Student Reference Book, page 263. It's your job to look those up. Right now then, you're going to get a half sheet of paper, and it is your job to do this journal right. Explain the difference between a line segment, and ray. You may include drawings or symbols to explain. Your teacher will collect this and dismiss you back to your classroom when you are completely finished with the journal write. Go ahead and get started. Make it a great day.